Everyone loves winning a competition, but the Maritime RobotX Challenge has such a grand scale that for the teams participating, designing their boat is about more than just winning.
It's also about furthering their research agenda beyond the competition. And an autonomous WAM-V is an extremely capable platform for doing just that.
We use this vehicle daily. The past year, we saw efforts through the Florida Department of Transportation to autonomously map underwater bridges using forward-facing sonar systems to look for cracks and to get divers out of danger.
Journals are becoming increasingly selective about saying, simulation results aren't enough. I want to see this work in real life. All of these real-time system problems, as well as, real-world robustness issues, play into when someone says, I ran this at the RobotX competition, I'm like, that probably works really well then.
Teams may select their sensors and algorithms for the purpose of pushing the envelope in their research, even if it actually makes preparing for the competition itself more difficult.
Teams also make far-reaching design decisions to extend the usefulness of the platform beyond the competition.
They want to make sure these capable robots can be research workhorses in the intervening years, both for themselves and for other collaborating research groups.
So back when I was doing the 2013 RoboBoat competition, we needed an inertial navigation system, but we couldn't drop tens of thousands of dollars on a commercial one. So at that point I realized I had to build my own. 2 years later I have the hardware working and the team's using it and they're happy. And so I'm starting this company called Silphase, and I plan to market it towards companies that are developing autonomous vehicles, in addition to academic users who are doing research.
We've got some research partnerships with School of the Environment, who do sandbar monitoring, and also looking with the South Australian Department of the Water. They can't take a petrol boat into the supplies because you'll get contamination for water supply for the city, but an electric boat with no emissions is something that's of interest to them.
Dr. Eric Johnson, who runs a lab at Georgia Tech, currently uses the boat to land autonomous helicopters on it while it's on the water, while it's driving. And you could absolutely use the dynamic model that we've developed. They do use the hardware that we've worked on. The WAM-V has really opened a lot of doors for collaborative research.
Surface vehicles occupy a unique position between the domains of land, air, and water.
So teams are also designing their RobotX entries with a focus on interoperability research.
Some of this even involves the use of their entries in other RoboNation competitions.
So right now it's really hard to talk with AUVs underwater. Currently they have to use an acoustic modem, which are about 56K baud rate, so it's not a lot of bandwidth to transmit data. But if it connects to an ROV, which has a tether to the surface ASV, it can send up to whatever the network is rated at.
No matter where they end up in the competition rankings, having the incentive to build a cutting-edge robotic research watercraft is a win-win situation for everyone involved.
To find out more about the research being performed by these universities, follow the links from the Teams page at robotx.org.